So let's go to the transcendental functions, and um, these are functions which are not algebraic, and there are four of them. And what we'll be discussing first will be the trigonometric integrals. So as we progress, so we also discuss the other types of transcendental functions, which are the inverse trig, the hyperbolic, and the exponential functions. So I think in this case, if you remember your derivatives or the counterpart derivatives of your transcendental function, so I think it's a much easier approach if you just try to remember those formulas before. So sa derivatives, okay, magbali-bali ra ang mga formula. All right, so let's begin. So these are the formulas for your trigonometric integrals, and there are 10 presented on the screen, but usually what you will find most in the books is kani siyang 1, 2, 3, 4, and then 7, 8, 9, 10. So these are just the common integrals which you can find on books or on searching the internet. So usually ang kaninyong the checked formulas are those having a counterpart on your derivatives. So for example, you have integral of sine u du, and then the answer is negative cosine u plus c. So usually when you try to have the derivative of this one, derivative of cosine is negative sine, diba? But ang negative lang diri is not lang sa atong cosine, diba? So same goes for your sine. The derivative of sine is cosine. So na back and forth na sila, diba? If you try to remember your derivative. Same goes for the other um, formulas. So as you can see here, so there are um, you have negative ln cosine u plus c. So if you try to, or if you have navigated through the Canvas platform, so the other answer for this one is ln secant u plus c. Secant u plus c. So why is that? Because if you try to look at the negative symbol here, so as per property of logarithm, so this will be the exponent of the inside function of the logarithm. So this is the exponent of cosine u. And this becomes cosine u to the negative 1. And then we all know that if any term or any expression is raised to the power of negative 1, it automatically goes to the denominator, diba? So that's 1 all over cosine u. And we know by fact by by trig nga kuan na basic kind of properties katong sine cosine, so it's equal to secant nga function. So you might wonder ano kuan basin later on lahi atong answer later on ba. So different authors have different ways of presenting their formula. So muna. So it could be either be the way of kaning answer ninyo. It could be ln negative ln cosine u, or it could be ln secant u plus c, right? So secant squared u, tangent u. So I think you also have this one in your derivatives. A derivative of tangent is secant squared, di ba? Same goes for cotangent. So I believe in the derivative of cotangent u is negative cosecant squared. So same goes for number 9 and 10. So these are just the reversal of the other sa derivatives, di ba? Okay, so what better way to appreciate the formulas is by answering some problems. So we're going to answer 8 problems today. So let's go to the first one. So we have the integral of cotangent x dx. So you might wonder why I presented this type of problem we're in, it's already in the answer, diba? It's already in the formula, which is ln sine u plus c. So let's try to verify that one. Ln sine x plus c. So what if you forgot the formula? So one way is, of course, we try to answer this one in a basic manner. So we try to break down the cotangent function into its basic parts, which is, so cotangent becomes the integral of, so we know by fact that cotangent is cosine x all over sine x dx, right? So by u substitution, so we can have the u sub technique. So it's called u substitution. U substitution. So it's replacing a term with letter u and then trying to derive it. So I think the ultimate objective of u sub is to create a simpler expression of the formula or of the equation being presented for us to be able to use the formulas being given to us. So again, the purpose of u sub is for you to take the complicated expression into a much simpler version of it so that we may incorporate the basic formulas being given to us. So for example, in this manner, so we let u be equal to something. So let u equal to something. And then after getting the u is we try to derive it with respect to its variable. And so that's always the next step. So of course, if you look at the steps, so we let u equal to something, and then the second step is that we get the derivative of it. So of course, we try to look for terms that can be easily be derived, and of course, we try also to look into the expression above in such a case that we can do the substitution technique directly. In simpler terms, kuhan siya, when you try to substitute the different values later on, ma-replace tanan. Okay? So in this scenario, notice that the cosine dx is in the numerator, di ba? Because this one is dx over 1. So this is multiplied as a whole. And then we have another term here, which is sine x. All right. So of course, if given the situation above, so I can say that my u term should be sine x, because when I get the derivative of sine x, this would become cosine x. And then we have dx, diba? So notice that cosine dx is in the numerator. So what I do here is I just multiply dx to the other side, which gives me du is equal to cosine x dx. So notice now that this becomes my du parameter. And then this one becomes my u parameter. Okay, so transforming the equation. So we now have the integral of, so cosine u du. So again, this term here is going towards here. And then the u parameter is going towards here. So we now have du all over u. So notice that this is what this expression here is the basic formula presented on the first activity, or on your first asynchronous activity, which is more on the basic integrals. So by formula, this is ln u plus c. And then, of course, don't forget to bring back the value of the u parameter. So the final answer would be ln sine x plus c. So notice that it's the same answer as the formula. So that's how you do with the formulas kanang complicated. Kanang pili pa ma-breakdown. So try not to memorize all the formulas. So you can just memorize a few or the few important ones. Katong akong gi-check is I think orto siyang very important. Katong number 5 and 6 medyo kuan na siya kanang additional information ito siya na formulas. Okay? So do you have questions for the first item? Okay, so I guess there's no question. So let's try to proceed with the next example. So just try to bear with the color sa mga solutions. Okay, I'll try to um, shift it from time to time. So next is the integral of cosine 5x dx. So if we try to answer this by formula, integral of cosine is sine, diba? So we can say that the answer is sine 5x plus c, diba? Now when we try to verify our answer, so one way of verifying your answer if it's correct is by deriving the final answer sa inyong integral. So kani siya, ato ni siyang i-derive. So let's say we try to derive this one. So the derivative of this one is cosine 5x. And then we try to derive the angle again. So the derivative of the angle 5x is 5. And the derivative of constant is 0. So the answer is 5 cosine 5x. Ba? So if you try to notice the given integrand sa inyong problem, it's only cosine 5x. But when we try to verify our answer, it's 5 cosine 5x. So meaning this answer is not correct. So the question is, how about the formula, sir, di ba? Mamunta yung gihatag and then should it be the formula wrong? So actually, the formula is correct, but it's lacking in detail. So if you try to remember the formula, cosine 5x, kuan siguro, di siguro 5x, but let me erase lang siguro. So it's the integral of cosine u du is equal to sine u plus c. So this formula is only true if the angle has no coefficient or the coefficient of the angle is 1. As you notice here, the coefficient of the angle of the cosine and sine function are both 1. So meaning it's it's a direct answer, diba? But for problems having an angle, coefficient for the angle, so the exact formula for this one, when you go into deeper mathematical books, such as BS math books, so ilang formula is cosine AU. So A being the coefficient of the angle, U. Now the answer or the corresponding formula for this one is 1 over A sine AU plus C. So this is the conjugate original formula. So kana mga formula nga gi-present sa books nga walay coefficient, so those are just generic formulas. Yeah, di man takabot sa author, di ba? Because I think basin ang ilang aim is for the readers to be able to understand it directly. Basin siguro ang deeper sense of it will come later on once you have appreciated the basic concepts. Okay, so mo na siya ang correct formula in mathematical books, in BS math books. But again, in most books kanina dyan siya ang present. So if you try to answer again our problem, so this becomes 1 over 5 sine 5x plus c. So muna siya ang iyong answer. Now if we try to verify this one by getting the derivative, so we have 1/5 cosine 5x times 5 plus sine 5x times 0 plus 0. And this will cancel out the 5 out, and then what you have is cosine 5x only, which is the same as the given problem. So question is, kano inani man akong kwan? So if you try to recall your derivatives, so we have what we call as the product rule, diba? So this one is u, this one is v. So u dv plus v du, diba? Then of course this one is the constant, that's why it's 0. So for those of you who have forgotten, ano na siyang pag-derive, so muna siya. That's the product rule of differentiation, having two different types of functions. All right, so questions? Hello? Okay. Sige, so we try to go to the next problem. Okay, it gets difficult by the number. Okay, so we go to the third problem. So we have the integral of sine x minus cosine x over sine x dx. So in most problems, I think what your approach should be is that you try to simplify first the expressions given. So try not to make it hard on yourself by dapat muna akong button, I need to follow this process, I need to follow these steps. But I think um, the very first step in solving problems is to first simplify the expression. So for example, in this case, you can say that I can divide this into two fractions, di ba? So before jumping into conclusions nga, I should do u sub or inana. So I need to simplify first my expressions. So I can divide this one into two terms. So meaning sine x over sine x minus cosine x over sine x dx. So notice I placed a parenthesis because I want to imply that the integral sign is applicable to the two terms. Okay, so that's the purpose of enclosing it on a parenthesis. All right, so simplifying even further, so we can say that this one is sine over sine is just 1. Then cosine over sine is cotangent x dx. So again, by um, by implication that I need to integrate the two terms inside the parenthesis. So the integral of a constant is x. So this gives me x. And then the integral of cotangent x coming from number 1, that is minus ln sine x plus c. All right. So that's number 3. So I think important note here in splitting fractions is that if you have this term, excuse. So for example, this one is reversed, diba? So let's say you have sine x minus cosine x. So you cannot split these terms, diba? So most of my students before, if they have this kind of fractions, ilagay pong split into this kind. So dili siya ma-split because there's only one term in the numerator. So even though the denominator has two terms, so always take note that the numerator is being divided by the denominator. So if isa ra ang term sa numerator, so meaning this whole thing will divide sine x. And again, you cannot split it unless you have a couple of terms in the numerator. So just try to to be mindful of those mistakes. Okay, so let's go to number 4. So we have here the integral of z plus 2 dz all over cotangent z squared plus 4z minus 3. So in this note, so I think we can use the u sub because we are presented with a difficult um, expression. So again, first step is to simplify the given expression. But if you cannot simplify it, so you can simplify it by using u sub. So let u be equal to something, and then again we take the derivative, diba? That's always the two steps of u sub. And then the third step is replacing it. So complicated expression here is the angle of the cotangent. So this gives us the z squared plus 4z minus 3. So that later on, when we try to express cotangent, it's only cotangent u, dili cotangent z squared plus 4z minus 3. Diba? So mas simpler siya tanawon, diba? So next is we take the derivative. So derivative of the given expression u with respect to dz. So this gives us 2z plus 4, diba? Then plus 0. So pitira walay 0 para di na ta magsigsuwat og kanang kuan balik-balik. So notice that in the numerator, it's z plus 2 dz, right? This one here. So if we try to multiply dz on the right side, so du becomes 2z plus 4 and then dz. So marag duol-duol na siya og dagway, di ba? We only have to tweak it a little bit more for it to be able to look like the numerator in the given expression. So we factor it by 2. So this gives us 2 and then z plus 2 excuse me, z plus 2 dz. So notice that this term is already the same as the ones on the one above, but now like coefficient at 2. So we get rid of the 2 by dividing the whole expression by 2. So this becomes du over 2 is equal to z plus 2 dz. Alright, so notice that we can now, so let me use another color lang para inyo ma-appreciate. Okay, so this one becomes du over 2, the numerator. So kana siya ko, it's just for the sake of kanang inyo makita kung asa siya padong. So this one is going towards the numerator, and then this one is going towards the denominator. All right, so since we can now replace every term in the expression, so again, I think aside from making the expressions a bit simpler, the other objective of the u sub technique is for you to be able to replace every term in the equation. So dili lang isa but tanan, right? So this gives us du over 2 divided by cotangent u. So by magic, this becomes 1/2 tangent u du. So ano na naman na siya? So again, if we do it in basic terms, du divided by cotangent u, di ba? And then the reverse of it, which is multiplication, that is 1 over cotangent u, diba? 1 over cotangent u. And we know by fact that it's 1 over cotangent u is tangent, diba? Imo na siyang gibali-balik. So this becomes du over 2 times tangent u. So muna siya. Alright? So you may take the 1/2 outside the integral symbol. As per basic property, you may take out the um, constant number. So this becomes tangent u du. So this becomes 1/2. So negative 1/2 ln of cosine u plus c. So again, you may also do away with the other answer, which is 1/2 ln of secant u plus c. So of course, don't forget to bring back the value of the u parameter. So this may be expressed as ln cosine of z squared plus 4z minus 3 plus c, or di katong inyong positive counterpart, which is the ln. 1/2 ln secant of z squared plus 4z minus 3 plus c. All right. So questions or clarifications for this item? Okay, question. Kuan, ako i-change ang color sa karita. So, gikan na siya dire, kani siya. This expression. So, ako lang siyang kana manually divide. So, this one is division. Diba? If you divide the next term, okay, or the denominator, it's the reciprocal, diba? So, that's why it's 1 over cotangent u na siya. Diba? Ako na siyang kana step by step lang na. Basta maglibog mo ba? Okay. Sige, sige. So any other questions before we move to the next example? So I think there's none. So let's go to number 5. So the same technique, use subgyapon. So again, we try to make things look simpler for us to be able to use the formulas. So let u equal to something, and the next is the du part. So you may also not write the dx anymore, and then just try to multiply dx right away on the right side para di mo magsigig du over dx. Okay, so for me to be able to look at it at a simpler manner, so I want to eliminate ln 4x squared. Okay, para later on when I make the substitution part, I only get cosine u, di ba? I won't be dealing with ln 4x squared. So let u is equal to ln 4x squared. Okay, so if you try to recall your derivatives, the derivative of ln is du over u, di ba? So this being the u, 4x squared being the u. So since the formula for the derivatives is for ln is du over u. So we get the derivative first of the first one. So this becomes 4 times 2 times x, di ba? and then all over u, which is 4x squared. So again, you may just write dx right away on the right side, dx, para di naman magsige cross multiply, di ba? So kato kanina is I just showed it for the sake of kanang the step-by-step process. So cancel out 4, cancel out 1x, and what remains is just 2 dx all over x. So notice in the numerator, in the given expression above, we have dx over x, di ba? But on our u sub process, we have 2 dx over x. So we divide everything by 2 so we can eliminate the 2 on the right side. So this becomes du over 2 equals dx over x. So this time is that we can now make the proper substitution. So as you can see, everything can be replaced in the expression. So this becomes the u parameter. Then this becomes the du over 2 parameter. So this one here. Then this one going towards u. So in simpler format, this becomes cosine u and then du all over 2. So d over 2 is 1/2, so you may take 1/2 outside the equation. And it becomes even simpler given that our expression is just cosine u du, which is a standard formula. So integral of cosine is sine. So you have 1/2 sine u plus c. And then bringing back the value of the u parameter, this gives us 1/2 sine ln 4x squared plus c. Okay. So questions or any clarifications regarding this number? Okay. So if you notice that murag ang ato ang style, di ba, will differ per number. So muna try to be observant on how we deal with problems. So some might not literally take on the use sub process. Some kay murag simplification lang and then it leads to a simpler version. Then you can just use the formula. So let's try um, to um, to review this one later. Okay, so next is we move on to the next problem. We have the integral of cosine squared 1/2 x dx. So kani siya medyo labad na sa o, di ba? Kay we don't have any formula for cosine squared x or cosine squared u. Formula for your say integrals. So matong problem karon. So karon is I think we need another approach for us to be able to answer this type of problem. So since kamutanan nakagayong mo trigonometry from your high school or let's say advanced trigonometry in your senior high, so hopefully you can recall some of the different identities that you were able to discuss during those times. So those identities will still be useful in simplifying our equations in these types of integrals. So karon for the sake na di ta madugay or for the sake na inipungtahan ako ninyo basin di pa mo unsa nga type of identity akong kailangan gamiton. So I'll just give you the answer right away. So you're going to use the half angle identity. So again, These are only just one of the few groups of identities in your trigonometry identity. So we have the Pythagorean identities, the sum to product, the product to sum, the quotient, di ba? Na. So daghan kayo kanang kuan identities. So by formula is that you have cosine. So cosine theta over 2 is equal to the square root of 1 plus cosine theta all over 2. So that's the formula. So other books may represent it as cosine squared theta over 2. Then the right side is 1 plus cosine theta over 2. Na, it will depend on the author of the book. So murag eliminate lang ang radical symbol. So by squaring everything, so muna nahimo ng cosine squared ang isa. Then ang isa, ang right side is wala na siya. So it doesn't have any radical expression anymore. So other books also, kung dili 1/2 or kung dili theta over 2 ang expression, it could be that the expression is, so I'm gonna put it here. So cosine theta, diba? And then it's going to be square root of 1/2 cosine 2 theta over 2 na in some books. Or if wala siya kuan, it could be cosine square theta is equal to 1 plus cosine 2 theta over 2. Ana. So either of the four ang inyohang gamiton, ana, pare-pareha siya naong tanan. I think it depends on how the formula will be used. Okay? So let's try to use this formula. Kani akong i-box kay para mas dali. So if we try to dissect the identity, so this is theta over 2. So theta over 2. So coming from the problem, this is the angle, diba? Notice it's cosine squared theta over 2. So cosine squared theta over 2. So again, the purpose of I'm using this format also because it's cosine squared in the given expression. Yan diri is cosine squared pud siya. So theta over 2 is equal to 1/2 of x. So we could state it as x over 2, di ba? So notice that we have a theta here. Atay theta diri. So theta is equal to, so multiplying 2 to the other side, so theta is just equal to x because the 2 will cancel each other out. Diba? So, okay na ta, diba? So we can now replace, or we can now transform the equation into a better looking equation or simpler version. So we now have, so instead of cosine squared 1/2 of x, so ang ato ang button is kanina siyang right side kani. Ato na siyang gi-convert into its other format, di ba? From this format going towards another format. That's the beauty of the identities sa inyong trigonometry, di ba? So aside from proving, di ba, mo tatong ibuhat sa una sa high school, sa ato ang kuan, mag-prove tag mga equations or sa senior high, di ba? So karon is we'll use the identities into creating a better expression for the equations. So don't forget the parenthesis. So this becomes 1 plus cosine theta. So again, our theta is this portion here. Theta is equal to x. So this becomes 1 plus cosine x all over 2 dx. So again, we can create two different terms here. So the integral of 1/2 plus cosine x over 2 dx. All right. So again, you need to integrate this one and also this one. Or if you want to separately create two integrals, so you may also do so. So distributing the integral, so you have, um, if you want to distribute this, distribute also the dx. So it will look like this: 1/2 dx plus cosine x over 2 dx. And then taking away the constant, so 1/2 integral of dx plus 1/2 integral of cosine x dx. And this gives us the answer of 1/2 x plus 1/2 sine x plus c. All right. Questions? So I think murag wala pa may question, di ba? Because I think this is super new kay murag matag ni go back in time to recall the different identities for us to be able to answer this problem. So muna labad-labad sa ng math no kay murag sumpay-sumpay ra pud na siya tanan sad. Murag subconsciously sumpay siya, wala ka naka-realize nga sumpay lang day siya day ana. Maka-realize ka later on na katong yun nakatunan sa una is importante day sa other subjects pud. Alright, so next is we have another half angle problem. This time it's sine squared 3x dx. So again, we don't have any formula for sine integral of sine squared x, di ba? So what we need to do is we need to use the formula. So for half angle sine, hello? Inside, marag wala naka-mute yung mic. Okay, so going back to the discussion, so the formula for the half angle of sine squared is sine theta over 2 is equal to 1 minus cosine theta all over 2. So I think it's the same as the cosine squared half angle, but ang iyang difference is the operation of its counterpart. So ang sine squared theta over 2 is 1 plus cosine ra over 2, but ang sine is 1 minus cosine theta over 2. So again, looking at the format, so 3x will become the half angle. So meaning theta over 2 is equal to 3x. And then again, since we have a theta on its counterpart, so isolating theta, so multiplying 2 to the other side. So this becomes theta is equal to 6x. And then we can now write the formula. So the integral of 1 minus cosine 6x all over 2 dx. So again, you may create two different integrals for this one. So 1/2 minus cosine 6x over 2 dx. So this gives us two different integrals. So 1/2 dx, na pina-shortcut gamay. And then 1/2 integral of cosine 6x dx. So usually I want to be safe with my steps. Ako siyang i-breakdown kay para later on when I try to review my answers, ako siyang ma-track even better, di ba? Kay maraghan ay ang pag-apply sa anang kuan ba, solution. So dili ko mawala. So if ever marong ko, so at least makita din ako kay since step by step ang kwan pag present sa mga solutions. So this becomes 1 half x minus 1 half. So again, notice that there's a 6 na coefficient sa inyong cosine function. So this gives us 1 over 6, 1 over a. Integral of cosine is sine. Then ax, that would be 6x plus c. So final answer would be 1 half x minus 1 over 12 sine 6x plus c. And that would be the answer. All right, so questions? Hello? Okay, so I think there's no question. So let's proceed to the last problem so that we can have our early dismissal. Kay basin gipanggutom naman muna, di naman mutingog. Okay, so last problem is that we have this integral of sine 3x cosine 5x dx. So as you notice, medyo problematic ta because we cannot directly use u sub because the angle of the sine function and the angle of the cosine function are different. 3 and then the other one is 5. So it's difficult for us to use the u sub because dapat better siguro mag u sub siya if you just have the same coefficient, di ba? Mas dali siya. But since it's different, so medyo maglisod ta, di ba? So so one way of trying to solve this problem is we're going to go back again to our identities and we're going to use the product to sum identity. So hopefully naka-remember mo na. Product to sum identity. Kana siya. Alright? So if you try to recall the formula, this would be sine A cosine B is equal to 1 half. So ako lang iyan bracket sine A plus B and then sine A minus B. So that would be the formula. So this one is plus din plus. Alright, so other books. Ang other books pud kay ilang way of representing this one is kuan pud siya kanang dili 1 half but it's 2 sine AB, 2 sine cosine B, and then sine A plus B. So I think this one is minus man siguro ni siya. It's plus the plus sine A minus B. So ana. So depende na sa kanang kuan sa inyong book or sa inyong reference nga gitan-aw sa inyong identities. But again, the same na siya kay murag multiply ra ang 2 sa other side and then kani siya kanang kuan di ba? Mag the same ra. If you divide mo sad, may mo siya siyang inani sad. The one above. Okay? So since the first format is a bit similar with the given expression above, so we'll use this formula or this type this format. So we need to take note that A is the angle of the sine function and then B is the angle of the cosine function. So A being 3x and then B is equal to 5x. So notice that there's an a plus b expression here, a minus b expression on its counterpart or on its identity. So a plus b, so meaning that would be 3 plus 5. This will give us 8x. Next is a minus b. So 3 minus 5, this will give us negative 2x. All right, so I think we can now solve the problem, or we can now create another expression using the identity. So our new expression is now 1/2. So you may take 1/2 outside the equation directly para wala siya samok. So this gives us sine. So a plus b is 8x. Then plus a minus b, that's 2x. So sine negative 2x dx. Okay, so simplifying it even further, so this becomes 1/2 integral of sine 8x, and then this becomes minus. So minus sine 2x dx. So if you're going to ask me ano na mo siyang negative, so there's an identity wherein you call a negative identity. So I think mo siguro na negative angle identity or negative angle identity wherein if you have a sine negative theta, this gives you negative sine theta. And then katong cosine nga negative is just positive cosine gyapon ana. So try to look on the identities. So negative angle identity. So lain po ni siya nga kuan sad. Okay, so um, creating two different kinds of integrals. So we have 1/2. So again, distribute, distribute, distribute also dx. So this gives us 1/2 integral of sine 8x dx minus 1/2 integral of sine 2x dx. So integral of sine is negative cosine. So this gives us 1/2. So take note that there's a coefficient on the sine function. So this gives you negative 1 over a. That's negative 1/8. And then cosine 8x. So next is minus 1/2. So again, there's a 2 coefficient on the next expression. So negative 1/2 because the integral of sine is negative cosine. So we have cosine 2x plus c. So I'll just write the final answer on the lower left. Okay, one space. So 1/2 times 1/8, that will be negative 1/16. Cosine 8x. And then negative 1/2 times negative 1/2, that would be positive 1/4. Cosine 2x plus c. So this would be the final answer. All right. So questions or clarifications? Okay, so if there's none, so I think that would be it for today. So the next session will be on Tuesday because we need to do some catching up with our topics para at least we can cover most of the topics by the end of the first half before midterms.